Greetings to all the viewers. The session is going to cover with the compound called oxole, which is alternatively known as a furan. Furan is the most familiar heterocyclic compound with the oxygen heteroatom in the five-member cyclic ring system. And the session is powered by AI, artificial intelligence powered session it will be. And here we are going to discuss about heterocyclic compound series of sessions already conducted in the earlier sessions where various heterocyclic compounds were introduced over there. All are available at the channel World of Competitive Chemistry. Today we entered into the concept called furan. IUPAC nomenclature is oxole. For this one, oxygen is taken as a heteroatom in the five-member ring system. Let's go with what is the agenda for this session. We are going to introduce the introduction for the compound and what are the synthetic protocols in order to manufacture furan in the synthetic floor like laboratory or else industrial scale manufacturing. Properties in general, which included with various physical properties like melting point, boiling point, density, every concept taken into the consideration, and the chemical reactivity. In what way it will react with any other reagents, giving rise to a new compound that is called its chemical reactivity, and eventually potential applications in the field of medicinal, pharmaceutical, agricultural, and material chemistry plethora. Let's enter into today's concept called furan, where brief introduction is taken for this segment, right? Brief info regarding this furan compound now going to be discussed. Furan is an aromatic five-membered heterocyclic compound with the molecular formula of C4H4O. It consists of four carbon atoms and one oxygen atom in the planar ring structure. Oxygen atom contributes two lone pair of electrons. One is taken part of the aromaticity. In either is the lone pair resided freely. Right. So here is the five-member ring system. Four carbon atoms are present and four hydrogens are resided within the molecule. Oxygen taken as a heteroatom. C4H4O is the molecular formula, and three-dimensional view is also provided for the better understanding. And here you can clearly observe oxygen pertaining with two lone pair of electrons. One lone pair contributed for the aromaticity. 6 pi electron system will be satisfied within the ring structure. Any other lone pair is free for its mobility. So that is located in the oxygen, which is not the part of aromatic ring system, right? This is the way of furan ring system is mentioned. It is a five-member ring system. Let me go with the potential applications which are included for this furan molecule. Furan-based oxygenated compounds are available. This is the most important substance manufacturing of biomass. Biomass is nothing but energy pertaining potential organisms whichever present from which we are able to extract that energy in the form of biomass, right? So furan-based medications also available in the pharmaceutical industry and even material chemistry applications you can observe, being it is a substance procedure for the polymerization. And furan-based resins also available in the market and global market. Also consisting this furan-based resins. Resins are having the property of a kind of plastic nature. Interesting furan containing drugs are manifested over here. Ranbazolit. Ranbazolit, it is an antibacterial. You can observe here is the furan nucleus and here is the saturated nitrogens containing heterocyclic benzene nucleus is there. Here is the kind of nitrogen oxygen together existing in a five-member ring system. This is the kind of molecule, polyannular system it will be. Ranbazolit. Ranbazolit is an antibacterial drug. Here is the another compound where you can notice the furan nucleus within the molecule called nifurtide. Nifurtide is an anti-infective. This is used to cure the kind of pathogens which cause the infections. So anti-infectious drug it will be nifurtide, where furan is located within the skeleton. And another one is most important, everybody aware about ranitidine. Ranitidine is commercially valuable under the trade name of Zantac, and it is most important as a antihistamine receptor, H2 histamine receptor antagonist. It will be ranitidine is used to curate the ulcers. Gastric ulcers can be prevented by means of ranitidine. Zantac is a trade name of the compound, and here is another compound called furanol. Furanol is a perfume distilled from the strawberries. From the strawberries, we will extract the perfume that is composed by this kind of furan nucleus within the molecule. Now, let's see key characteristic related with this furan nucleus. Furan nucleus ring composition is present where oxygen atom is of sp2 hybridization. All the remaining carbons also pertaining to sp2 hybridization that used to induce the planarity within the molecule. Being it is aromatic in nature, all atoms are laying in the same plane, and that is exactly resembling with the representation where all sigma bonds are generated due to the sigma bond formation is mainly due to what axial overlapping, whereas unhybridized p orbitals are located on each atom included with carbons and oxygen as well. These are unhybridized orbitals, and unhybridized orbitals responsible for pi bond formation. They are participating in the pi bond formation and giving rise to 6 pi electron system within the molecule. And p electrons which are located on the oxygen atom, they are contributed for the 6 pi electron system. And another 2 electrons which are present on the oxygen in the sp2 hybridized orbital, they are not the part of sigma bond formation. They are non-bonding orbital, non-bonding electrons which are located on the oxygen, which are free. Right, this is the way entire representation of chemical composition is provided for this furan molecule. Let's see how it able to find its bonding strategy related with the furan molecule is manifested over here. Carbons are indicated with the double bond. So 2 carbon double bonds are located within the furan molecule. Oxygen atom adjacent to the 2 carbons are located over here. This is indicated with the number 1, number 2, number 3, number 4, number 5. This is way numbering is provided within the molecule, and whatever oxygen present here, 2 lone pair of electrons are present, and one of the lone pair is the part of pi electron system, 6 pi electron system contributed by carbon atoms and oxygen as well. Aromaticity. So in order to satisfy the aromaticity, certain rules must be fulfilled, right? Any molecule said to be aromatic whenever Huckel rule is obeyed. So in order to obey the Huckel rule, 4n plus 2 pi electron system will be there. Let me calculate 4n plus 2 pi electron system. This is a kind of ring structure where 4n plus 2 electrons are located within the molecule. 4 multiplied with n must be whole number or integer value. And let me put n is equal to 1, being it is a ring 1. So that n is taken as 1, 4 into 1 plus 2. So if we apply this, so that 4 into 1, 4 plus 2. So 6 pi electron system. Here also you can locate 6 pi electrons within the molecule. So that 4 and plus 2 pi electron system is perfectly obeyed by the molecule. And pi electron system consisting of 4 pi electrons which are contributed by the carbon-carbon double bonds. 2 carbon double bonds are releasing 4 pi electrons, and 2 pi electrons are released from this oxygen heteroatom, right? As a part of lone pair of electrons, they are also contributed in the aromatic ring system, so that 6 pi electrons got indicated by this furan molecule, so that we can designate the molecule as aromatic in nature. And also planarity is assumed to be existed. That is because all the atoms are in sp2 hybridization. Bond angles and planarity, right? All the atoms are sp2 hybridized, so that ring is said to be a planar in nature, and the expected bond angle for sp2 hybridization will be 120. Everybody aware sp2 hybridized orbitals must located in such a pattern where 120 bond angle should be exerted. But in contrast, within the molecule, there will be a shortening of bond angle. 108 is the existing one. This is the practical assumption. This is the theoretical existence, right? 108, that is deviation from the expected bond angle, is because of the ring strain. Within the molecule, ring strain is observed. That's the reason why 120 concised into 108 degrees bond angle. And another reason beyond this will be electronegativity of the oxygen atom, right? That is also manifested in the lobes. So p orbitals are mentioned in the lobes form. So here is the oxygen indicated with this blue color where two lone pair of electrons are taken. uh, Whatever p orbitals of the carbon atoms in the same alignment, these oxygen lone pair of electrons also present. The all p orbitals are in the same alignment, so that all are participating in a lateral overlapping, giving rise to pi bond formation. Whereas another two electrons which are perpendicular in nature with respect to these p orbitals, this sp2 hybridized lobe will be 90 degrees angle, so that it is perpendicular. It is not the part of this pi electron sextet, rather it will be the lone pair electron resided on the oxygen for free. And here oxygen's lone pair of electrons and how it able to taken part in this aromatic ring system, right? So oxygen's role to be manifested. One lone pair of electrons in the p orbital resides within the aromatic ring, and one another lone pair of the electron system not the part of aromatic ring, right? So all lone pair of electrons are delocalized in nature rather than static, rather than fixed positions. All pi electrons are moving here and there. These pi electrons are shifting, and these pi electrons are shifting, these pi electrons are shifting. So that delocalized pi electron system is generating a cloud of pi electrons above and below of the plane, so that it is electron rich in nature, more susceptible for the electrophilic aromatic substitution reactions. Now let's enter into another segment called synthesis of furan. How can we go for the synthesis process, right? Polymer synthesis is the most important strategy in order to convert the open chain molecule in the cyclic aromatic ring system, where I'm taking diketone. 1,4-dicarbonyl compound was taken as a starting material, can be blended with acidic conditions. Upon acidified conditions, this diketone is transformed into tetrasubstituted furan. This is a substitute for furan as the final product. In order to explain this transformation, we have to go through its mechanism. Initially, protonation of one of the carbonyl group is possible, being acidic medium is taken in the environment, so that acid able to release the H positive and one of the carbonyl oxygen will be protonated. Later on, intermolecular cyclization is proceeded, giving rise to hemiacetal kind of intermediate, and subsequent dehydration giving furan as the expected product. In order to explain that one, let me take this 1,4-di ketone that is acidified conditions to be applied over this diketone molecule. Upon applying acidified conditions, aqueous conditions are applied over there, so that the starting step will be the protonation. H positive will attach to the oxygen, so that here oxonium ion will be generated, that generate the electrophilicity at the carbonylic carbon. This carbon is having strong tendency to bind up with the more electron-rich species, that is the carbonyl lone pair of electrons are contributing the bond with this carbon atom, that able to generate a 5-member ring system. Being lone pair taken as a bond formation, so that electron deficit indicated with the electropositivity over the oxygen atom. Later on, the 5-member ring system is able to neutralize this electropositivity upon the oxygen atom by taking the pi electrons towards the oxygen. Whenever pi electrons are moving, this carbon is deficit. In order to satisfy this valency, adjacent hydrogen will be removed by means of water. Water is amphoteric in nature, able to abstract the H positive, so that lone pair on the oxygen able to pull up this H positive, so that bonded electrons among the carbonate hydrogen are taken part of the pi bond formation. And the another pi bond which already existing is moving towards the oxygen in order to retain the electron pair, right? So that here the double bond formation is originated. Already existing hydroxide is there at this carbon atom. That existing hydroxyl existing hydroxyl is further protonated by means of acidified conditions. Again, whenever it is protonated, what it will do, the lone pair of electrons in the oxygen will moving over there, so that here is the double bond formation and subsequent removal of water from this cyclic ring system so that dehydration is possible. After removing that water molecule, that water able to absorb this H positive from this adjacent position. Whenever H positive is removed, the bonded electrons are striking towards the pi bond formation, and existing pi bond is moving back towards oxygen in order to satisfy its valency. So that there is a new double bond formation among the carbon and carbon atom. Already existing double bond here we already generated, so that it is the kind of furan derivative we synthesize starting from diketone upon treating with acid catalyzed conditions by the process called Paul-Knorr furan synthesis, right? Let me go with another named reaction for the synthesis of furan. Phase binary synthesis is subjected, where alpha haloketone is one of the reactant and 1,4-diketone is the another reactant. In order to proceed for the phase binary furan synthesis, let me take alpha haloketone, alpha chloroketone treated with 1,4-diketone in mild basic conditions like pyridine. Whenever pyridine is applied, there is a formation of furan derivative which is accompanied by the ester RL's carbonyl linkage at the position number 3. So in order to explain this mechanism, let me take alpha haloketone over there and beta keto ester was taken. These two are taken as the starting materials and treated with either pyridine or sodium hydroxide base, so that there is a formation of a furan with the ester linkage at the position number 3. Right, substituted furan will be originated by the condensation between the alpha haloketone with the beta keto ester. Let me explain the detailed mechanism in order to make this cyclization process starting from these two materials. Whenever this beta keto ester was treated with the base able to take this active hydrogen whichever present on active methylene group. Whenever H positive is removed, carbene will be originated. It is highly stabilized because of two adjacent carbonyl groups, so that carbene will participate in the enolate formation. This enolate will back polarize the negative charge, and these pi electrons are able to bind up with this carbonylic carbon atom, so that new carbon-carbon bond formation is possible. This is called Oldal reaction, right? Oldal reaction is proceeded. There is a new sigma bond existing between the carbon and carbon atom, and here the pi bond is polarized toward the oxygen. O minus or generated already, right? So this O minus is subsequently protonated. Protonation carried giving rise to hydroxyl, right? So that protonation, and here keto group again participate in the enolation. So keto-enol tautomerism is obvious in case of this kind of condition is existing. Later, let me proceed for the cyclization process. O minus is moving towards this carbon atom in order to form a new sigma bond, and subsequent halo is a better leaving group can be removed from the system, so that the existence of 5-member ring system is possible. Already double bond existing within the molecule, so that is persisted. Isolated intermediate is a kind of dihydrofuran derivative, right? Let me go for the protonation further. Whenever protonation is carried, aquated acidified conditions are applied upon the molecule, so that hydroxide will be protonated, giving rise to oxonium. Oxonium is better leaving group. In order to remove this one, bonded electrons also departed in addition to this water. So bonded electrons when removed, what happens immediately? Adjacent proton will be removed from the system and making this pi bond over this carbon and carbon atoms that able to retain this furan moiety within the ring structure, and ultimate elimination of water and H positive is possible. This is the way phase binary reaction is processed in order to attain the substituted furan molecule. In order to get this one, alpha haloketone is one of the starting material and beta ketoester is the another starting material. Let me go for another possibility for the synthesis of furan for fural decarbonylation. Fural is nothing but whenever furan is as a carbonyl linkage at the position number 2, palladium carbon is the catalyst applied together at the temperature of 200 degrees centigrade that proceeded for decarbonylation. CO Carbon monoxide will be removed from the system, giving rise to unsubstituted furan as the final product. So in order to explain the mechanism, in the presence of palladium carbon, the mechanism proceeded with the free radical homolytic fusion. Perfurol initially departed with the H dot. H radical will be departed or removed from the system. That able to generate the carbon free radical. Carbon free radical ultimately removes the carbon monoxide from the system. Whenever carbon monoxide removed, there is a carbon free radical again by breaking up this carbonylic linkage, so that here is the carbon free radical upon this aromatic ring system. Later on, let me add H radical so that here furan ring will be generated. This is the way furfural is also used in the manufacturing of furan by decarbonylation. Removal of CO is called decarbonylation. This requires the elevated temperature 200 degrees centigrade. And the catalyst like palladium carbon together are able to decarbonyl, and there is a formation of unsubstituted furan. Let me go for dehydration of 1,2-diols. 1,2-diol is nothing, sorry, 1,4-diol. 1,4-hexane diol was taken. 1,4-hexane diol is a kind of material where hydroxyl groups are located in the first and fourth position. Sulfuric acid is the better dehydrating agent to remove the water, so the dehydration will be carried in order to achieve this saturated furan, which is called tetrahydrofuran. Tetrahydrofuran can be reduced, tetrahydrofuran can be oxidized by the removal of hydrogen atoms in the presence of palladium carbon, giving rise to 2-ethyl furan as the final product. So this is the way a diol can be converted into a furan derivative by the dehydration and subsequent removal of the hydrogen atoms. Now, let me go with another method of synthesis called mucic acid. So, we can take mucic acid as a starting material. It is the polyhydroxy. It is the polyhydroxy dicarboxylic acid. Let me count number of carbons: 1, 2, 3, 4, 5, 6. 6 carbon chain it will be, where 2 carboxylic acids are present, and else we have 4 hydroxy, right? So it is a kind of adipic acid derivatives. Tetrahydroxy adipic acid is called mucic acid, where 2 carboxylic acids are located on the terminal carbon atoms, and remaining 4 carbons are located with the 4 hydroxyl. So the polyhydroxy dicarboxylic acid it will be. It is subjected to dry distillation process. Whenever distillation is carried, dehydration is the obvious condition. Dehydration giving rise to a double bonded compound, and moreover, it participated in the cyclization as well. And one of the carbon is accompanied by the carboxylic acid, and within the ring structure, we have ether linkage, that is a furan. Furan with the carboxylic acid at the position number 2 is called furoic acid. This furoic acid will participate in the thermal decomposition. Thermal decomposition is nothing but upon rising the temperature, carboxylic acid will remove this carbon dioxide as a byproduct and giving rise to furan as an unsubstituted product. Or else, decarboxylation is also accompanied by copper powder. Upon treating with furoic acid with the copper powder, furan will be a product. Quinoline is also the catalyst which is potential for decarboxylation process. Either of the method we can adopt in order to convert furoic acid into a furan product. Let me go for the another method of synthesis. I am taking pentosan. Pentosan is a kind of polymeric substance I am taking with the 5 carbon atom chain. Acidified aquated conditions are applied over there that able to generate a monomeric substance which is a pentose. Pentose is a kind of what? It is a carbohydrate moiety. Aldehyde containing polyhydroxy compound it will be. It is the pentose. Pentose subjected to what? Dehydration. So let me remove the water molecule from this again. Again, it participate in the dehydration and subsequent cyclization. That cyclized product is a furfural. So in the earlier, we got the carboxylic acid at the position number 2. In this section, we got aldehyde. That is called furfural. If carboxylic acid is there, called furoic acid, furfuroic acid. Carbaldehyde is there, that is called furfural. Furfural is the product generated from this pentose molecule by dehydration process. After getting this furfural, we have to go for decarbonylation. Again, CO to be removed, carbonyl group to be removed. In order to remove the carbonyl group, let me apply zinc chromate or else manganese chromate. Zinc chromate, manganese chromate applied over there, so the decarbonylation carried at elevated temperature. We need to boil at extremely higher temperature at 400 steam conditions to be applied, so that unsubstituted furan will be generated. Or else, furfural can be blended with palladium carbon. Catalyst will drench the reaction conditions to the normal level. Elevated temperature now shifted to normal temperature 200 degrees, comparatively low rate. So the decarbonylation giving rise to furan as the final product. These are another methods for what synthesis of furan derivatives. Diacetosuccinic ester was taken. Succinic ester is nothing but dicarboxylic acid with the 4 carbons is called succinic acid. Whenever succinic acid is esterified at their terminal carboxylic acid, that is called ester, disuccinate ester. If 2 carbon atoms are located with the acetyl at this position, so that we can say diaceto succinic ester, we can convert this acetyl ester into a ketoenol form. Tautomerism is applied over there, so that let me place ketonic groups. Let me replace ketonic groups with enolic groups. So enolic form is existing because of tautomeric isomerization. So later, let me apply this concentrated sulfuric acid upon this molecule. Sulfuric acid is a dehydrating agent, better dehydrating agent. In order to remove water molecule, let me remove H positive from one of the hydroxyl, OH minus from one of the carbon atom. Ultimately, water will be eliminated, giving rise to a 5-member ring system with the side chains. This is a nucleus called water furan. Right. Let me proceed for another method of synthesis. I'm taking alkyne. Triple bonded compound was taken and treated with Grignard reagent ethyl magnesium bromide. And here the N-butyl carbaldehyde was taken. This is another reagent added upon this molecule. Whenever all these molecules are added, what happens? This carbon is added with hydroxyl at the one edge, and another edge is added with butyl, because it is the Grignard reagent. Grignard reagent always having natural tendency to extend the carbon chain, right? Now let me apply Lindlord's catalyst. Lindlord's catalyst is more specific for what? Lindlord catalyst is more specific for the reduction of triple bond into double bond, in specific to the geometrical isomerism. Lindlord always giving rise to cis isomer formation. Here is the alkene generated that is cis in nature. Later, let me go for sulfuric acid and treating at 100 degrees centigrade, rising the temperature and acidified conditions are applied upon this alkene. So here is the molecule. You can locate our ether. Ethers are located upon this, and whenever acid is added, they got converted into hydroxyl and subsequent dehydration, giving rise to furan derivative. And moreover, here butyl is located in the carbon 2, so that butyl is located in the carbon 2 remains as such, and here the retention of the aromaticity. This is the way alkynes will be transformed into furan derivatives by treating with a number of reagents. Initially, Grignard reagent and subsequent aldehyde. Later on, Lindlord's catalyst is applied and sulfuric acid is applied on the olefin, giving rise to substituted furan. Let me proceed with another method of synthesis, ring expansion. 3-member ring system will be transformed into 5-member ring system by the enlargement of the ring size. Lewis acid is applied, boron trifluoride is the efficient Lewis acid in order to convert this one. Epoxide was taken initially, that is highly sterically strained ring system. 3-member ring is not that stable. And in the presence of Lewis acid, it will follow for the ring expansion. And this is opening of the ring. This is participating in the opening of the ring, so that here terminal hydroxyl will be generated. And here is the double bond located over there. This molecule further go for ketoenolic tautomerism later on, cyclization giving rise to substituted furan as the final product. This is called what? Ring expansion reaction. Now I entered into another method of synthesis, that is 1,3 butadiene. Butadiene is the 4 carbon chain. We are having alternate double bond system. Copper chloride and oxygen will be applied on this molecule, and the process is called oxidation. It is added with the oxygen molecule giving rise to furan as the expected product. Furan is generated later. Again, whatever we discussed as of now, that same reaction, resembling reaction is manifested over there. Epoxide was taken. Here is the acetylenic triple bond. H2SO4, HgSO4 together. H2SO4, HgSO4 are able to convert epoxide into dihydroxyl compound. Diol will be generated. The diol further proceed for the ring cyclization reaction within the molecule, giving rise to furan derivative. This is the furan which ever generated starting from epoxide. Triple bond in conjunction with the epoxide, if treated with the combination of reagents like sulfuric acid and mercury sulfate, that able to generate the product furan with the diol as an intermediate. From the other heterocyclics, I am taking oxazole as a starting material. Oxazole is the kind of material where oxygen, nitrogen together existing within the 5-member ring system. And another triple bonded acetylene was treated on this oxazole molecule. Whenever triple bond is applied over there, there is a kind of a Diels-Alder reaction giving rise to that able to generate the norbornene type of derivative. This norbornene derivative will go for the removal of the moiety of this nitrogen part, and that able to generate this furan derivative in addition to this phenyl nitrile. So this is the cyano existing upon the benzene ring, so that we can say phenyl nitrile will be the byproduct, and the remaining there is a this sigma bond participate in the pi bond formation in between, and this pi bond is relocated in order to make the conjugated system, and ultimately this sigma bond is moving over there, and in order to generate this carbon nitrogen triple bond, this is a nitrile triple bond. This is the way oxazole will be transformed into furan upon reacting with acetylenic triple bond, right? So the reaction mechanism proceeded with the bridgehead compound. Later, it will go for the cleavage of the cyclic ring. Here we are having bicyclic ring system that is participating in the ring cleavage, giving rise to 5-member ring, one edge, in either 6-member ring with the nitrile and the other edge. Let me go. So the contrary with respect to this one, 3-membered converted into 5-membered, which is called ring expansion. Now let me explain another possibility called ring contraction. Ring contraction stands for if we are making the higher to lower, that means 6-member ring system, if transformed into 5-member ring system, that is called water ring contraction reaction, right? So here I'm taking a pyridinium salt, a kind of oxygenated, pyrrhelium salt. It is not pyridine, it is the oxygen heteroatom, so that let me pronounce pyrrhelium salt. Pyrrhelium salt was taken, treated with H2O2 hydrogen peroxide. What is the nature of hydrogen peroxide? It is the oxidizing agent. It able to cleave this ring system and generating the intermediate diketone compound. This diketone compound will go for the recyclization. Within the system, recyclization is proceeded that able to generate 2-acetyl furan. This is called what? Ring contraction. In order to operate ring contraction on this pyrrhelium salt, hydrogen peroxide is a suitable reagent under acidified conditions. Hydrogen peroxide having tendency to cleave this 6-member ring system and generating intermediate called diketone. Diketone will relocate the cyclization again, giving rise to 5-membered furan ring system. Let me enter into the segment called properties of the furan. As of now, we gone through the various synthetic routes for in order to manufacture the laboratory scale furan skeleton. Now we entered into another segment called properties of the furan. In order to explain the properties, initially it will be the kind of liquid and smells like ether. Ether resembling odor will be indicated and sweet in nature some extent, and it is colorless substance, colorless kind of liquid that is furan. Molecular formula we already aware about: four carbons and four hydrogens, one oxygen resided, so that C4H4O is the molecular formula, and it weighs 68.07 grams per mole. So this is indicated as a molar mass for the given compound. Boiling point will be 31.4 degrees centigrade, right? So 31.4 is nothing but just above the room temperature. So that by slight rising the temperature, immediately it will be vaporized, so that we can say this is the liquid called volatile in nature. Just like a petrol, if you open the tank of the petrol, what happens? Petrol will be volatilized. That will be vaporized. In the same manner, this furan is also having tendency of volatile, that vaporization, because of low boiling point value 31.4 degrees centigrade. By slight rising or hot conditions, it immediately vaporized. Melting point will be minus 85.6 degrees centigrade. If we are maintaining this cryogenic condition, then only we can solidify this furan. Solidification is accompanied at a minus 85.6 degrees centigrade. This is the melting point value. Let me show the density. Density is extremely smaller. Density of this furan will be 0.936 gram per centimeter cube when we are measuring at the temperature 20 degrees centigrade. Density comparison with the water will be obviously less, because water density will be 1 gram per centimeter cube. Its density is slightly lesser than that one, that is 0.93 gram per centimeter cube. So that let me mix up furan and water. So furan able to generate the layer. Both are immiscible in nature, because furan is a non-polar, water is a polar substance. So that furan able to generate the upper layer because of lower density, and water is the denser, so that lower layer will be occupied. So this is the way density will be compared with the water. Let me go for the solubility criteria. How can we dissolve the substance which is suitable? Water is a kind of polar liquid, and furan is slightly polar molecule because of the oxygen heteroatom, so that non-polar solvents are preferable in order to dissolve this one. Water solubility is extremely partial, sparing solubility we can notice, and organic solvents are more preferable in order to dissolve these furan substance, so that you can choose either ethanol, diethyl ether, or benzene as a suitable solvents in order to mix up this furan in a well manner. Flammability. Because of low boiling point value, immediately it will be vaporized, so that flammability is extremely larger. Fire catching ability is higher for this substance, so that it is the flammable liquid. Let me enter into another part of the session called chemical properties of the furan, right? So let me explain about the chemical properties. Initially, let me compare the reactivity. All the heteroatoms pertaining in the five-member ring system are nitrogen, oxygen, and sulfur. Among all, it is of moderate in comparison to the pyrrole. Pyrrole is of higher reactive, later oxygenated furan will be there, and the sulfur containing thiophene will be the somewhat least reactive in nature, and the extreme least of reactivity is accompanied by benzene molecule, right? So this is because all five-member ring systems are pi excessive in nature, so that they are having electron richness. They are more susceptible for electrophilic substitution in comparison to the benzene. But among all these, pyrrole is more reactive. That is because of low resonance energy. Furan is somewhat less reactive. That is because of electronegativity of the oxygen. It will withdraw the pi electron density towards the oxygen, so that some extent that electron density diminished. Sulfur is of larger, and 3p orbitals are the part of this pi electron system, so that they are not that effective contributing for this pi bond formation, and here the existence of pi electron density is comparatively less because of larger size of sulfur. Let me go for the aromaticity. How? can we explain the aromatic nature of the furan? Furan is a obviously aromatic compound and it obeys Huckel rule. Huckel rule is nothing but if any compound is online with the 4n plus 2 pi electron system, then we can say the molecule is aromatic in nature. Being furan is the part of aromatic substance, 4n plus 2 is condition is obviously followed. And delocalized pi electron system is located within the molecule. All unhybridized p orbitals are participating in the pi bond formation by bilateral overlapping. They are generating conjugated system within the molecule. 6 pi electrons will be there. Planarity will be satisfied. Speed of hybridization is the characteristic property of this one. So that they are aromatic in nature. They will not proceed for the addition. Rather, they will go for electrophilic substitution reaction, just like aromatic compounds only, right? This is the way the aromaticity of the compound will be explained, and uh, aromaticity in comparison to the benzene will be somewhat slighter, lesser. That is because electron withdrawing nature of the oxygen. Oxygen is the part of this ring system having tendency to pull up the electron system. The pi electron cloud is slightly migrating towards oxygen so that its aromatic nature will be slightly diminished. So this is the way aromaticity will be well explained. Let me go with the resonance. Resonance is nothing but all pi electrons are moving here and there always. That is making a cloud of electrons above and below of the plane. How the electrons are moving, pi electrons are loosely bounded, everybody aware, so that pi electrons having freedom in order to migrate, in order to move from here and there, so that delocalization of pi electrons are leading to more number of resonance structures. More the canonical structures giving rise to more the stability for the molecule. They will impart the high stability. They're indicated with the double-headed arrow because all the canonical structures are interconvertible, right? So you can go for the forward or else backward reaction as well, right? Lone pair also the part of aromatic ring system. So that let me contribute lone pair for the pi bond formation, so that subsequent adjacent pi bond will be migrated, that able to generate the negative charge over there and new pi bond existing. And here is the positive nature on the oxygen atom. Same will be repeated among all the resonance structures and ultimately giving rise to a kind of resonance hybrid over there. Resonance hybrid better indicated with the circle. The circle indicates the localization of electrons, revolving of electrons, the entire five-member ring system, that imparting partial negative charges upon the carbon atoms and higher electropositivity over the oxygen, because the electrons are contributed by the oxygen, that is indicated with the partial positive charge. This is the way carbons are electron rich and susceptible for electrophilic substitution reactions, that better explained with the resonance bonds. Let me enter into electrophilic substitution reactions of the furan molecule. Just like benzene, the molecule is also participating in electrophilic substitution because of aromatic nature. But in comparison to the benzene, it is more electron rich in nature. That is because 5 atoms, 6 electrons, so that electron density is higher in comparison to the atom contribution. That's the reason why it is the electron rich and more reactive towards electrophilic substitution. And resonance energy is also comparatively less in comparison to the benzene. Benzene is 36. This furan is 18. Thiophene is 29. If resonance energy is less, reactivity will be higher. Resonance energy is higher, reactivity will be less. Both are reciprocal with each other. Resonance energy is reciprocal of its reactivity. Due to the existence of less extent of resonance energy, the reactivity of this furan is higher towards electrophilic substitution. Furan is a pi-rich heterocyclic. As we are aware, it is pi-excessive substance and the electron density will be higher within the molecule in comparison to the benzene. And 6 into 10 to the power 11, 11 taken as a superscript, being it is a power, right? 6 into 10 to the power 11 times faster reactive with respect to electrophilic substitution in comparison to the benzene molecule. They are proceeded with the electrophilic substitution via addition elimination reaction. Sigma electron complex will be generated, canonical structures will be generated, more resonance contributed for more stability. This is the way C2, C3 are competing in electrophilic substitution reaction. But C2 is more favorable position for high stability, more canonical structures, higher the electron density at C2 carbon atom over C3 carbon. That's the reason why C2 and C5 positions are more favorable and susceptible for electrophilic substitutions. This is the way electrophilic substitution is briefly introduced. Let me show. Position number 2, substitution with the electrophile giving rise to 2 substituted, or else 3 substitution is also possible that able to generate the 3 substituted. Let me go with, there is a ambiguity where I have to go for electrophilic substitution, which is favored, which is possible. In order to explain this one, I have to go for the possibility. So the electrophile may added at the position number 2 first. Whenever electrophile is attaching at the position 2 and the subsequent carbocation at the position 3, the carbocation stabilized by delocalizing adjacent pi bond, so that carbocation at the position 5, and that may contributed with the another canonical structure. 3 possibilities you can notice whenever electrophile is coming at the C2 site, C2 position. Let me go with C3 position, C3 electrophilic substitution. Whenever C3 position substituted with electrophile, carbocation immediately satisfied by the lone pair of electrons of oxygen, and that retarding 2 canonical structures only. So it is the minor product. More the resonance structures, higher will be the product. So that major product will be 2 substituted. Less the resonance structures, lesser the stability contribution. So that minor product with this 3rd position substitution. This is the electrophilic substitutions. Now let me go for the halogenation. I'm taking furfural. Furan-to-aldehyde is denoted as a furfural brominated in the presence of dichloroethane. Dichloroethane is a solvent and slight heating is required. Bromo will be substituted at the position number 2, right? Let me go with the another halogenation reactions. Unsubstituted furan was taken. HgCl2 mercury chloride as is a kind of chlorinating agent. Sodium acetate is a catalyst applied, so that there is a formation of mercury chloride at the position number 2, because it is electron dense region, right? Later, you may add either bromo, iodo, or chloro, any of the reagent that able to generate halogenated product at the position number 2, right? This is the way monohalogenation is accomplished under mild conditions. We need to provide mild conditions, then only monosubstituted is possible. Otherwise, it will go for polysubstitution. That's the reason why I'm taking mild reagents. And this is called furoic acid. Furan is having carboxylic acid at the position number 2, which is called furoic acid. Chlorination is applied over there that able to generate chloro at the position number 2. Later I may treat quinoline. Quinoline or else copper powder will be applied. That is the decarboxylating agent. Carbon dioxide will be removed from the position number 5, so that here 2 chlorofuran will be generated. Or else, a simplest reaction is also provided. Furan can be treated with bromine in the presence of solvent dioxin. Extremely cryogenic conditions, -5 degrees are applied over there, and that able to generate 2 bromofuran. 2 bromofuran formation is possible. This is about glimpses of halogenation, right? Let me go for nitration. In order to proceed for the nitration, furan can be treated with nitroacetate. This is the molecule called nitroacetate, and treated at extremely lower temperature. Mild conditions are required because of higher reactivity of furan. -20 degrees if applied, that able to generate nitro substitution at the position 2 as a major product. Position 3 also possible as a minor product. Whenever this nitroacetate is the compound applied, that nitration is feasible due to the liberation of nitronium cation. Nitronium cation is able to attach at the position number 2. In order to synthesize nitroacetate, I have a starting material nitric acid together mixed with acetic anhydride that able to generate nitroacetate. This nitroacetate is the efficient nitro group containing species, nitroelectrophile rich species, and able to release nitronium ion, able to generate 2-nitrofuran as the final product. Let me go for alkylation. So furan subjected to alkylation, I'm treating with the bulkier molecule. Here is the larger molecule of benzene with the nitro at the position 2. Position 1 is the alkyl with hydroxyl group at this. That treated with the Lewis acid, ferrichloride, hexahydrate. Ferrichloride hexahydrate is able to add the alkyl group, being second position already blocked. So that let me go conveniently towards the position 5. So that position 5 alkylated, and this is a kind of alkylation reaction. Let me go for acylation. So it is proceeded for Friedrich acylation and treating acetic anhydride in the presence of Lewis acid, boron trifluoride, diethyl ether is the organic solvent. In contrast, you may add trifluoroacetic anhydride. So both are the acylating agents only, able to generate acetyl product at the position number 2 only. 2-acyl furan is generated as the final product. All these are the part of Friedel-Crafts alkylation and acylation as well. Let me provide a roadmap in order to explain the chemical reactivity of the furan. So all are tabulated in the simple form. Acetyl chloride is a kind of acetyl chloride is the kind of acylating agent in the presence of tin tetrachloride. Stannic chloride we can pronounce. That able to generate the acetyl functional group at the position number 2. So that 2-acetyl furan will be generated. Mercury chloride in the presence of sodium acetate together able to generate mercury chloride at the position 2. Later you may treat with acetyl chloride again, that able to replace mercury chloride with acetyl, so that again acetyl will be substituted at the position number 2. Let me treat acetic anhydride in the presence of boron trifluoride, that also giving rise to acetyl at the position number 2. Just we explained with this. So this is the way acylation is carried upon the furan, giving rise to 2-acetyl furan as the final product. Multiple pathways we adopted. Benzene diazonium salt is benzene diazonium chloride is the kind of reagent. It is more reactive in nature. Whenever it is directly treated with the furan, it able to generate a coupling reaction in the presence of basic conditions. Phenyl 2-phenyl furan will be generated. This is the reaction called coupling. Coupling reactions always proceeded with benzene diazonium chloride when treated with active compound. Most reactive substance to be treated. Obviously, furan is a reactive species, so that coupling reaction is feasible among these two species. Later, let me confirm the coupling reaction. I'm blocking position 2 and position 5. Furan molecule got blocked with position 2 and 5, and again diazonium salt, dinitrobenzene diazonium salt is going to work upon this, so that it may occupy the position number 3, so that other coupling product will be generated. Whatever other coupling product generated, that will be a better coloring agent, so we can use them as a dyes, pigments, coloring agents, right? So as a product, you can find the difference here. A diazonium salt only, but that diazonium salt is having the substitutions at position 2 and 4. Dinitro-diazonium salt is going to work upon this dialkyl furan, that able to retain this diazo compound within, and able to generate the azo compound. Azo coupled compound will be generated, right? This azo coupled product will be a coloring agent. Now let me perform the sulfonation. In order to perform the sulfonation, sulfur trioxide is an electrophile, that is called a neutral electrophile in addition to the pyridine. So when sulfur trioxide pyridine together are reacted, that able to generate the kind of salt form, that is pyridinium sulfur complex will be, sulfur trioxide complex will be generated, that able to release sulfur trioxide, that is a neutral electrophile. Obviously electrophilic substitution at the position number 2. Position number 2 and 5 both are susceptible to go for the substitution, giving rise to disubstituted product, that is disulfonic acid will be the expected product. Let me take perfurol as a starting material and subject it to what? Palladium carbon, right? Palladium carbon is a decarbonylation agent, so that a furan will be the product. This is the kind of application. In the synthetic part also, we gone through this one, and this is also taken as a property because we are taking furan derivative itself as a starting material. And the pure furan can be synthesized by decarbonylation. In order to operate, palladium carbon is the catalyst applied. Now let me treat alkene upon this furan molecule. Whenever alkene is working on this in the presence of phosphoric acid, instead of Friedel-Crotth, it will be proceeded with the alkylation reaction giving rise to two alkylated furan, right? So olefin is going to work upon this position too. And this is alkylated product you can achieve. Let me treat with the carboxylation. Carboxylation is nothing but addition of carbon dioxide. In order to achieve this one, this is the kind of reaction where organometallic compound, this is alkyl lithium, is applied upon furan. Alkyl lithium is able to pull up a H positive from this position number 2. Whenever H positive removed, a negative charge, a carbene ion will be there. That carbene ion whichever present will be added with Li positive. So lithium substituted product you can notice that can be treated with carbon dioxide. Carbon is experiencing electrophilicity. Carbene is directly going to bind with this carbon dioxide carbon and generates a new carbon-carbon linkage and further protonation under acidified conditions, giving rise to carboxylic acid. This is called furoic acid. So whenever furan treated with alkyl lithium, subsequently carbon dioxide giving rise to furoic acid. Now, we entered into the segment called nucleophilic substitutions. Nucleophile is nothing but negatively charged species replaces another negatively charged species. I'm taking this iodofuran, can be treated with sodium methoxide. Sodium methoxide is a strong base able to release O minus, that means CH3O minus, which is called methoxide. Methoxide is powerful so that there is a formation of methoxy substitution at the position number 3. Methoxyfuran will be the product. This facilitated by copper oxide catalyst. Methanol is a solvent medium. Let me take bromo and nitro substituted furan treated with this secondary amine. So that bromo, being it is a better leaving group, can be replaced with the amine at the position number 5. Now, let me treat this furan containing ester at the one carbon atom, that is fifth carbon, and second carbon is occupied by the bromo. 2 bromo, 5 ester substituted furan was taken as a starting material, can be treated with this pyrrolidine. It is a strong base and treated at the temperature 20 degrees to room temperature is sufficient, so that bromo will be better replaced with this piperidine, giving rise to substituted product. And sodium methoxide is a strong base, as already we are aware. Bromo will be replaced with this one, so that methoxy at the position number 2 you can achieve. Let me go with the named reaction called Birch reduction. Birch reduction is a controlled reduction or also partial reduction we can denote. Metal lithium dissolved in the liquid ammonia is a combined reagent. In order to perform this 1,1,4-dihydro alkanes will be generated. Here is the 2 double bonds, but when 2 double bonds are present, first position, fourth position hydrogenated, and 2 double bonds concised into 1 double bond, being it is a partial reduction, so that 3,4 dihydrofuroic acid will be generated. Already we are having furoic acid. Double bonds will diminish it into 1 double bond by this Birch reduction. Dihydro addition at the first and fourth position you can notice. And this is the product we can expect by this Birch reduction. Complete reduction. Let me remove all the pi bonds existing in the furan. For this purpose, let me add nickel dissolved, nickel metal added with the hydrogen gas, either palladium oxide is also in either alternative method to achieve this complete reduction, so that all the pi bonds will be destroyed and saturated tetrahydrofuran better solvent will be synthesized. Whenever we are treating this furan with air, open oxidation, which is also called as auto oxidation, right? So when furan placed in an open vessel, And direct contact with air that able to oxidize within the air, that giving rise to a malic anhydride, and further polymerization is also possible. This is called what? Oxidation process, because we are adding oxygens to this organic moiety. Later, oxygen also having provision to bind in another manner also, so that oxygen is generating a peroxy linkage within the molecule. Peroxy linkage is not that stable, so that immediately ring opening is carried, so terminal dihydroxy compound will be generated. This is the way oxidation reactions are performed upon this furan molecule. And these are some other furan to pyrrole generation is possible whenever furan is condensed with this ammonia in the presence of alumina. Alumina is a better dehydrating agent, and elevated 400 degrees centigrade temperature to be applied, so that pyrrole will be transformed into, sorry, furan will be transformed into pyrrole. Let me treat HCN, HCl, Z and Cl2. HCN, HCl, Z and Cl2 when applied upon this furan molecule, that able to generate aldehyde at the position number 2. It is again another named reaction, Catherine-Coach reaction, generating aldehyde over there. Nickel hydrogen able to remove all the pi bonds within the ring system, that able to saturate the molecule. Later, let me treat with ammonia at 500 extreme high temperature to be applied, so that oxygen will be replaced with nitrogen, and moreover, this will participate in the ring expansion and giving pyridine. So that pyrrole is the precursor for the synthesis of, sorry, furan is the precursor for the synthesis of pyrrole and pyridine as well, right? Otherwise, this furan to carboxyl to carbaldehyde, which is called furfural in general, that can be treated with KCN, which is called benzoin condensation. And either named reaction we can proceed just like benzene, benzaldehyde molecule. This furan carbaldehyde, which is called furfural, can participate in benzoin condensation, giving rise to furan. This is the molecule with hydroxyl and ketone together existing in the dimerized form called furan. Furan will be further oxidized. This hydroxyl will be transformed into ketone. This is the diketone called furyl. Furyl can be oxidized into furyl. Furyl will participate in a kind of reaction, benzylic acid rearrangement. Be aware about benzene, right? In the same manner, here sodium hydroxide, when operated, this is able to generate hydroxyl at this carbon, and another will be rearranged within the molecule, giving rise to sodium carboxylate, which is called a furylic acid. Furylic acid will be generated. These many transformations you can notice. This is most interesting laboratory scale synthesis and laboratory research focused area. It will be. These many transformations are possible by this furan. Let me go for the oxidation process. Oxygen will be added upon the furan, so that just now we gone through this one. Peroxide linkage is generated within the molecule. Peroxide is highly unfavorable. Peroxide linkage is highly repulsive in nature. That's the reason why, which facilitate the ring opening reaction. Ultimately, diketone formation is possible. Diels-Alder reaction is the most important application of the furan. Furan is generally, aromatic compounds are resisting Diels-Alder reaction, because Diels-Alder reaction is destroying the aromaticity. After the adductor formation, aromaticity will not persisted within the molecule. That's why benzene and thiophene, such molecules, may not go through this kind of Diels-Alder. Rather, furan, because of lesser resonance energy, because of hyperreactivity, it is a kind of violation from the aromatic characteristics, so that furan will go for this Diels-Alder reaction with the malamide. It works like a diene, and dienophile can be treated over at the temperature of 90 degrees and giving rise to adductor. It is the condensed product. It is the bridgehead product generated, that is called adduct. Diene treated with dienophile. Diene is the furan, dienophile is the malamide, and both are able to react a concerted mechanism. This is the kind of photochemical reaction we can say Diels-Alder reaction, giving rise to a adductor product. And the same will be performed with the malic anhydride as well. This is the one amide. This is the one ester. So that malic anhydride will be treated upon the furan in the presence of esternitrile solvent. Again, you can achieve the same product. And here also it is working like a Diene. And maleic anhydride acting like a dienophile, so that both are able to add in such a manner, giving rise to exocyclic ring system, that is adductor formation is possible. And here are two provisions here. Endo product is possible, exo product is possible. Exo product is more favorable. Major product will be exo, that is liberating the ring strain. So steric hinderness is less in case of exo product. Exo means all the anhydride bonds are wedged. That means towards the weir. That is inclined towards the weir, abo side. If the entire anhydride part is going away from the backside of this condensed ring system, that is the endo product, which is highly strained one, so that minor product it will be. So the favorable condition will be a exo product formation by Diels-Solder reaction. Let me extend the Diels-Solder reaction in between furan and a kind of electron withdrawing group containing double bond. This is a dienophile and treated giving rise to again the adductor formation. Indo-exo product formations are possible. This is the way adductor formation you can notice. And I'm taking I'm treating this ester containing sulfone moiety is present over there, and that is sodium sulfone salt will be there, and the furan will be treated over there. Hafnium tetrachloride is the kind of catalyst applied. So this sort of reaction in both the cases you can observe hafnium tetrachloride, right? So that able to generate again the adductor product. Adductor product will be generated, right? The clear reaction for the polymerization is manifested over here. This is another application per view. Regarding this furan, perfluoryl alcohol was the starting material, can be treated with paratoluene sulfonic acid. Paratoluene sulfonic acid is working like a catalyst. It is not the part of reaction, rather it is the catalyst, so that it able to manifest this kind of condensation reaction. Why it is condensation? We are able to remove this hydroxyl in the form of water, able to condense the molecule in such a manner. So furan resin will be generated. It is the kind of polymeric chain. Long length furan molecules are resided within the molecule by the elimination of water by the condensation. And paratoluene sulfonic acid is re-existed because it is working like a catalyst. Its role is the catalytic one, right? This is the way polymerization is proceeded. Let me show another chemical reactivity with the acids. Whenever furan reacted with acidic medium, protonation is carried over within the molecule. The position 2 will be protonated, being H positive will be electrophile, able to generate sigma complex with the canonical structures. Alpha protonation, beta protonation, both are possible. Alpha protonation is more familiar, and subsequent hydrolysis giving rise to ring opening reaction, and that diketone will be originated, right? So 1,4-dicarbonyl compound will be the product by the ring opening reaction, so that acids are able to open up the ring and generate the diketone as the final product. Reaction with amines. Whenever I'm treating with what is the material I'm taking? Secondary amine is the material treated over this kind of furan. Furan is treated with N-gamma N dimethylamine. So this kind of compound was treated, and this is the kind of alkylation we can say. Here is the CH2 N dimethyl compound was taken, so that will be substituted at the position number 2. Simply we can say it is the kind of alkylation only, rather than a reaction with amines. We can treat them as alkylation reactions only, because carbon able to bind up with the carbon atom. So this is the alkylation reaction in the presence of acetyl chloride and acetonitride. This alkylated product will be originated. Methyl substituted furan if taken. This is called formaldehyde, and dimethylamine everybody aware about this reaction, which is called mannich reaction, giving rise to amines. So here formaldehyde and dimethylamine together are able to generate this mannich base. So that kind of product formation is possible at the position number 2. Now we entered into the last segment of the session called applications of the furan. Furan is a part of agricultural chemicals and stabilizer. It will be pharmaceutical potent chemical pharmaceutical medicines will be manufactured, solvent for the resins. If you are taking furfural also finds its own distinct applications like industrial solvent, and weedicide remove the waste plants in the croplands. Fungicide, fungus will be removed from the croplands, and production of tetrahydrofuran, right? These many applications we can observe for the furan and furfural together. Let me see the applications in general. Organic synthesis, it will be the better intermediate and precursor for the synthesis of so many heterocyclic compounds as well, right? Medicinal perspective, if you go with the medicinal perspective, most familiar, most widely applied kind of medicine will be ranitidine. Everybody aware about ranitidine. It is a kind of antacid. Antacid is the kind of species whichever required whenever acid generation is more, ulcers are more, and stomach burning will be more. At that condition, the curation is required by suppressing the nature that is the well used medication called ranitidine. It is a work. It is working like an antacid, right? So it's a chemical composition you can clearly observe. At its core, you can notice the furan ring, and here is the secondary amine. Sorry, tertiary amine. You can notice sulfur is also the part of the skeleton, and here is the nitrogen, here is the nitrogen, here is the nitro. So it is the kind of medicine which is accomplished by the furan moiety within this ranitidine, which is the efficient antacid, right? And let me introduce another medical substance, potent medical substance, that is a nitrofurantoin. Nitrofurantoin is a kind of antibiotic drug. You can clearly observe it. The trademark medication you can you can observe over here. So it is the antibiotic working again is the bacteria. So that antibacterial potency is observed for this molecule. There is the furan nucleus at its core. Let me introduce another applications like a pesticide. Furan working like a building block in the synthesis of the pesticide. So pesticide which is indicated over here is the carbofuran. It is the better insecticide and herbicide as well, right? So in order to remove the pest, in order to remove the herbs, unwanted herbs over there, this carbofuran is more efficient in nature, right? And it able to introduce the flavors and fragrances because of its aroma nature. Caramel type of aroma smells are indicated, are exerted by these furan moieties, furan skeleton. That's the reason why flavoring agent it will be in a food industry, and fragrance in the cosmetic and perfumery industry, right? So this is the way applications like a pesticide, flavors and fragrance also indicated over there. Let me show the pharmaceutical applications of this furan. Furan is manifested over here. Purple color ring indicates it is a furan. And furan based antibiotic is mentioned over there, and nitrofuranol is there, nitrated furanol is there, that is effective infective disinfective agent. Disinfection is used to avoid pathogenic organisms which are causing infections, so that will be destroyed by this one. And furazolidinone. So furazolidinone, sorry, furazolidone. Furazolidone is the kind of antiprotozoal. Protozoans are nothing but unicellular organisms. So that protozoans can be destroyed by means of this kind of furan nucleus containing species, and it is a potent antibacterial as well. These are the kind of pharmaceutical applications manifested pertaining with the furan at their core nucleus. Let me introduce any other important societal benefit in the context of furan. It is used in the energy, moreover, renewable energy production, and also the biomass generation, right? Furan can be derived from the biomass, like furfural is extracted from the living organisms and considered platform chemical for the bio-based product. So many bio-based products can be manufactured, and moreover, energy collection is also possible starting from this biomass, so that it is the part of renewable energy. It contributes to the development of sustainable fuels and chemicals, so that plants are able to exert this furan nucleus at their core, and it is the main skeleton existing in the biomass of that plant material. Whenever we are processing this kind of polymeric substance in a strategic manner, that able to generate the renewable energy, it is a source of sustainable fuel, right? So this is a kind of a lignocellulosic biomass existing in the plant material. So many plant materials are contributing this lignocellulose biomass, where the cellulose content will be up to 50% and hemicellulose is up to 40% will be there. In the cellulose, existing components of the hydrocarbons are hexoses, and from this hemicellulose also contributing hexoses and pentoses as well. They are accompanied by the furan and their skeleton nucleus at their cellulose and hemicellulose composition. These are the important components, and they are contributing for the renewable energy production, and the sustainable energy generation will be possible, right? And in other applications, these are kind of distinct applications pertaining to the furan. Specialty chemicals can be manufactured. As we already aware, they are more reactive towards the reaction with the azo-dyes. Azo-dyes are nothing but diazonium salt materials. Azo-dyes are able to couple with these furan moiety, so that pigments and dyes can be manufactured, which are very essential in the textiles and printing as well. So that kind of coloring agents can be manufactured by blending with that diazonium salt, so that as a product will be generated, which is the important material in the coloration. Chemical sensor, it will be. Chemical sensor is nothing but whenever the kind of substance I'm taking, here you can clearly observe, here is the six-member ring system with more oxygens, and in the furan nucleus is located. Amines will be treated over there and heating to the higher temperature that able to generate the sensing agent, and the same material can be taken over. Amine will be treated with this one, and blending will be proceeded with this furan. Amines will be blended over there that able to generate the kind of material which is having the potential towards the chemical sensing and thermal sensing as well. Both the methods are used to applied over there, and that giving rise to a sensor tendency. Sensing tendency is nothing but they able to capture, they able to diagnose chemical substances whatever present, and thermal substances whatever present. That chemical sensors and thermal sensors can be manufactured starting from these furan material. This is the kind of material chemistry application. All together, these two together comes under the material chemistry applications pertaining to this furan moiety. It is a coloring agent. It is a sensor in the chemical industry, right? Chemical diagnosis, chemical detection is possible. Identification is possible. Chemical sensor we can denote. That is manufactured by taking the substance which is manifested over there, can be blended with amine and able to generate the kind of blended product you can clearly observe, which is having tendency of chemical sensing. By this way, successfully completed the entire session, accomplished with various segments, various domains, various pathways of the synthesis of furan, properties pertaining with the furan, physical properties and the chemical reactivity is clearly mentioned over. And what kind of applications we can observe in our daily life, in our at present research, at present application perspective. All the information whatever collected is really informative towards the viewers, and hopefully the session is very informative for the preparation towards any competitive exam, entrance examination as well, and also the people who are more familiar with the research in the field of synthetic organic chemistry, especially in the heterocyclic compounds. The content what we covered is most important in nature, right? So updated information and authentic information is gathered from various websites, and the session is conducted by Dr. Kavita Kotireddy Kota. So thank you very much for your patient listening. This will be very informative in nature. Thanks a lot.